Okay guys, in this lab we're going to be heat treating A2 tool steel and 4140 alloy steel. And you're going to be getting slices of that material, and you're going to need to keep track of which alloy is which. Now in this lab we're going to be taking the alloys up to austenitic temperature, so we'll have the furnace up above 1600 degrees Fahrenheit, and then we're going to quench them in a variety of different quenchant methods. Now the 4140 we're going to quench in water and we're going to quench in oil. So I'm going to go ahead and take the lids off of these and set them off to the side, and we're going to have our materials in there. Now there's little trivets in the bottom just like this to allow the water and the oil to move around that part when it sits in there on the trivet. So we're going to be able to see the even cooling as it goes down there and lands on that trivet. And then what we're going to do to get that out is we're going to take the little magnet over here and we're going to fetch our part out, and we're going to be able to get our part out. Now when we do that, you're probably going to want some paper towels so you can wipe this clean as you retract your part and you get it out. So I recommend having 4 or 5 paper towels ready for when you get your part out of the tanks here. Now when we put our parts, let's talk about some safety in our quenching methods. The water, pretty simple and safe. You're just going to be able to drop your part in there. The oil, you want to drop your part and leave it in there. Don't try and get it out, just drop it in there and leave it, okay? It's going to cool rather quickly. The other things we want to talk about safety is, again, you're going to need your lab coats on. We have a whole bunch of blue lab coats just right over there. And you're also going to need the high temperature gloves. Now don't get these into the water and the oil. These are just when you're loading and unloading the samples in and out of the furnace. Now I have the furnaces off right now, and this is a furnace that typically we would use for this activity, and it would be up at 1600 degrees, and we wouldn't want to open it and get our hands in there. What we're going to do is we're going to make little carriers, part carriers like this, to put our part into. And what we're going to do is set our part in there in the middle of it, and we're going to set it down over here, and we're going to have our gloves on, okay? And with the furnace on and the gloves on, right now I'm doing it without the gloves just to show and save time here. I'm going to lift that up and not touch the sides, and I'm going to leave my part sitting in there. Now you're going to notice we're going to need a lot of the furnaces on for this lab because that takes a lot of the space. You need to remember which sample went in what furnace. You're going to put it in there and leave that for 30 minutes. That's going to get it to soak at austenitic temperature. When it's done, you're going to come in here with the gloves on and your tongs, and you're going to pick this up, and you're just going to move it over, and you're just going to drop it right into the quenchant tank that you need to. The deal is, we would love to have you guys make pouches and control the atmosphere and not get surface scale on the parts, but due to the size of the parts, and we want to have really good results, we need to be able to go from the oven into the quench tank smartly, really fast, okay? Now, we kind of learned when we did the geometry samples, a lot of people had a hard time opening a pouch. We had some groups taking over 2 minutes just to get the part out of the pouch and into the tank, and that allowed the parts to cool and not get the proper quench trajectory going through the TTT diagram. So we're going to ensure that by just taking it directly out and dropping it in the correct quenching tank. And don't throw this away. Leave it over here by the furnace, or just leave it right here, and that'll leave it for the next group that maybe needs to use those little carriers to carry the part over. The other nice thing about those carriers is we're not using the tongs. The tongs we have are great for blacksmithing. They're really big and large, and when we grab that little part, it's going to suck the heat right out of the part, again altering our results. So being hot in the hot carrier, that's going to keep our results spot on. Now whenever the part cools down again, you're going to come in and you're going to fetch your part out, and you're going to be able to use the paper towels to dry that off and process it. So this would be a quench sample if I'd had the furnace on and everything. And then what we're going to do is on the 4140, you're going to have one that's quenching oil and one in water, and we're going to do a dye penetrant test on that. Also, what we're going to do is do a tempering process on these parts and see what happens. So you're actually probably going to get 4 samples, so 2 of them in water, 2 of them in oil. Some of them are going to go to the dye penetrant, and some are going to go right back in the furnace to be tempered. and we're going to temper that martensite to a certain hardness and take the hardness values afterwards and compare it to expected results in the heat treaters guide. So yes, you're going to need to do some research in the heat treaters guides, and we covered that in the lecture for this lab. Now, if you're dealing with the A2, you're going to carry it out from the carrier, and you're going to be able to set it out right there on the trivet on the cart, and that's going to let air flow around that part and air cool, okay? And that's going to air harden. So the 4140s are going oil and water, the A2s are going to go here. You're going to end up with 6 samples in all, 4 of them being 4140, 2 of them being A2, and we're going to do our quenching and tempering with those materials. Now then, let's go over and look at the dye penetrant area. Okay, we're at the dye penetrant area in the vent hood, and what we want to do is take our part and get it clean and get all the scale off. We're going to have a cleaner that's going to be right here, and we're going to do all of our chemical spray within this one chamber, not on the other side, just in the designated area. And we have a little shelf back here for us to put the part on when we want to spray it. So you notice I have my part back there, and then I can come in and spray it. So I'm going to take this cleaner, I'm going to shake it up, and I'm going to spray it on. And you notice it really cleaned the part off, and it got everywhere. And I'm going to come in and rub, and that gets all the oil and grease off of the part. Put the cap back on the cleaner. The next thing we need to do is going to be our dye that we're going to spray on there. So I'm going to set my part up there, and if I'm doing the oil quench and the water quench, it's probably good to have both of them up there at one time. We're going to shake this up, and then I'm going to come in here and wet that surface where it's pretty wet. I'm going to let it sit for a number of minutes and let the dye soak in to that part, okay? And once it soaks in, after about 5 minutes, we're going to come in with a rag and wipe that surface clean. Now, one of the things I didn't show is that part, when we took it from the oven, it's probably going to have scale and everything. So you're going to need to take it to the wood table and remove this scale with some of the abrasives and get that to a nice clean surface. And I didn't show you that step before I got here, but you need to do that before you clean and put the penetrant on there. So it's been 5 minutes now, and we're going to take our part, and that dye is going to get all over your hands. So I recommend not picking it up with your hands. If you want to use gloves, I would recommend using some gloves, because this dye is going to get everywhere, guys. This dye is just going to get everywhere. What you want to do is come in here with a towel, and you want to wipe all the dye off that part. Do not spray it with cleaner or put it in water. We're going to come in there and get all of that dye off. Now I'm going to use a new towel, and I'm going to come in here and just make sure that I got all the dye off of it, and that white towel really shows if there's any of that red dye on there, okay? Now I've got my part cleaned up, and now I'm ready to come in with some developer, okay? I'm going to go ahead and wipe this back shelf off that we have there, and I'm going to put my part up there, and I now have the developer. And what I'm going to do is shake it up really good, and I'm going to come in there with the developer and put that on the part and let it dry. And what's going to happen is that's going to pull the dye out if there's any dye in cracks, and we're going to be able to observe that after it dries. So again, you might need to let it sit for 2 to 3 minutes and dry. Now, I've let it sit for 2 or 3 minutes, and if I look at this, I can see that I do have some cracks in this part. And so this has quench cracks in it, okay? And that's not an acceptable part. I can really see it blotting out on the developer there. So you're going to check the parts, quench in oil and the water, and see how they compare to each other. Now in this lab, you are going to have to take and perform Rockwell test. Since we've quenched these, the 4140 and the A2, we definitely need to make sure we start with the Rockwell C scale and get our hardnesses. We're going to compare those to anticipated or expected hardnesses per the heat treaters guides and see how we did. Now, the samples that are going to be quenched and not used for dye penetrant are probably going to go back. We're going to have some that go back and get used for tempering, okay? And so you're going to go back to the furnace and put those parts in at a lower temperature using, and we really don't need to use the little carriers. There you could just put the parts inside the furnace, because when we get the time that they're supposed to soak at that temperature, which is going to be about 45 minutes to an hour. We're going to set those out on those little trivets and let them air cool to touch. Now, the 2 samples that we did the dye penetrant on, we're going to clean them up and we're going to take them over, mount them, polish them, and etch them. There's going to be some samples already prepared for you that have been annealed, and you're going to be able to compare the annealed sample with the as supplied, as well as you're going to be able to compare your quenched and your tempered samples under a microscope.